Okay, here is another problem that we are going to see right today. In our today's lesson, we are going to see the application of derivative, especially how we are going to determine the monotonicity nature of a function. Now, here is the problem. We are given this function, and this function is given to be monotonically increasing. Now we are asked to determine the interval to which this function is monotonically increasing. Now one tip that you should have to understand is that a function is said to be monotonically increasing if and only if the first order derivative of the given function is positive or greater than 0. On the other side, a function is said to be monotonically decreasing if the first order derivative of the given function is negative or less than 0. Now, the second thing that you should have to note right here is that the given function is a pure rational function. Now, for a pure rational function, to derive, we are going to apply the quotient rule. I think from your derivative lesson how to use the quotient rule. Here is the form, as you can see. This is the form. Now applying the quotient rule, now let us derive the given function f of x. Now the derivative of f of x is equals to, now just by corresponding with the formula of the quotient rule, first we're going to derive the denominator. The derivative of x is 1 and multiply by the denominator function minus the denominator function as it is multiplied by the derivative of the denominator function, and this whole expression will be divided by the square of the denominator function. That's what the quotient rule says. So the entire expression will be divided by the square of the denominator function. Now, next of this is a matter of simplifying this expression. I think it's very simple. So as to simplify the given expression, it's a matter of gathering like terms in the denominator part of the expression. Okay. And in the denominator part, nothing is changed. X squared plus 1 the whole square is written. Now, upon simplifying this expression, you will ultimately get 1 minus x squared divided by the denominator expression as it is. Now, for further usage, the denominator expression 1 minus x squared can be further factorized into linear forms as 1 minus x multiplied by 1 plus x. It's just applying the difference of two square formula. Okay. Then after, so as to determine the monotonicity interval of the given function, we have to construct a sign chart for the derivative function. Here we are going to write all the factorized forms of the derivative function. So in the denominator we have these two, and the entire denominator has to be written right here. Um, so the ultimate product and quotient will give you the derivative function, and the zeros are -1 and 1. Now, because this -1 and 1 can make the derivative function 0. Now the first part, factorized part, will have these signs, and the second one plus x will have signs this one. But the third part is always, because it's a squared function, it's always positive. And upon multiplying and dividing all these signs downward, you will get these final signs for the derivative function. As you can see here in this interval, the derivative function is positive, that is greater than 0. Now, bear in mind, previously we have said that a function is said to be monotonically increasing if the first order derivative of the given function is positive, and it is positive between -1 and 1. So we can conclude that this function is monotonically increasing in the interval between -1 and 1. Now we have already done the problem, so the answer for this particular question will be choice D. That's it. Thank you very much. Don't forget to subscribe. Thank you.